So let's look at these questions. These are from 10C. Find the stationary points for each of the following. Well, we want to get the derivative. Find the stationary points. 3x squared minus 12. And at the stationary points, the derivatives are going to equal 0. So we let that equal to 0 and solve it. So if I factorize 3 out, I've got x squared minus 4 equals 0. Therefore, x squared minus 4 equals 0. X squared equals 4. X equals plus and minus 4. Now we want the stationary points, so we know that x is negative 4 and x is positive 4. You have to substitute 4 into your equation here. So f of 4 is 4 cubed, or f of negative 4 is negative 4 cubed minus 12 times negative 4. So 4 4s are 16, 4s are 64, negative 64 plus 48. So that's 10, 16. And substitute f is positive 4. We get 4 cubed minus 12 times 4. So 64 minus 48. Oh, this one was negative 64. This is positive 16. So negative 16 and positive 16. All right, and that's the stationary points. Let's look at 2b. Well, that was 1a. Find the stationary points for the following functions. We want to get the derivative. Now we've got a u, v. So u is x, v is log base e of 3x. So the u dash is 1, and v dash, the derivative of log, is 1 over 3x. That's the first bit, times 3. So we get 1 over x. So the u dash is v u dash minus u v dash over v squared. So it's v u dash, which is 1, minus u v dash, which is 1 over x, all over v squared, which is, oh, no, this is wrong. That's the quotient rule. Let me just, all right, let me just fix that. I'll use pink for where I'm fixing it. Because it's a product rule, not a quotient rule, it's just vu dash plus uv dash. It doesn't matter if it's v or u, v dash or vu dash. So it's vu dash plus, okay, so that becomes, the derivative becomes, because it's a product rule, not a quotient rule, it's the log of 3x plus 1. Okay, now we want stationary points. When does that equal to 0? Well, let's solve f dash x equals 0. So log 3x plus 1 equals 0. So log 3x equals negative 1. So e to the power of negative 1, e to the power of negative 1 equals 3x. Therefore, x equals 1 over, take the 3, and e to the negative 1 is e. Okay, so we found e is, x is 1 over 3e. It's between 0 and infinity. That's fine. And all we need to now do is find the y value. And we put that into our original equation. Y equals 1 over 3e times the log of base e of 3 times 1 over 3e. And y equals 1 over 3e times log to base e of e to the negative 1. And this all equals negative 1. So the answer is negative 1 over 3e. And that's the stationary point. 3b. That curve has a stationary point when x equals negative 1. Find b. All right, so when x equals negative 1, which means the derivative of negative 1 will equal 0. So when x is negative 1, the gradient is 0. So the derivative of negative 1. Well, let's find the derivative of x first. So it's 3x squared minus 2b x minus 9. Now substitute negative 1 in there and we get a 0. Substitute negative 1 in there, we get a 0. So 3 times negative 1 squared minus 2b times negative 1 minus 9 is going to equal 0. So 3 plus 2b minus 9 equals 0. So 2b equals 6. Therefore b equals 3. So b equals 3. Final question. Tangent to this curve at the point where x equals 2 is the same as parallel, which means the gradient will be the same as this line. And the gradient of that line is the derivative, dy dx, of 4x is 4. So the gradient is 4. Parallel, if the gradient of that line is 4, then the gradient of the tangent is also 4. Both gradients are 4 to be parallel. So therefore, if I get the derivative of this, dy dx equals 2ax plus b. Now that derivative will equal 4 when x is 2. Therefore, the gradient will be 4 when x is 2. So we get 4 equals 4a plus b. Okay, there's one equation. What else are we told? There is a stationary point at 1, negative 3. So the derivative of 1 is equal to 0. So if you substitute 1 into the derivative here, you'll get 0. So 0 equals 2 times a times 1 plus b. Therefore, 0 equals 2a plus b. And there is a second equation. All right. And we know that when x is 1, y is 3. So we can find c later. So let's find a and b first using these two equations. I'm going to use substitution, elimination. So if I just equation 1 minus equation 2, I get 4 take away 0 is 0, 4. 4a take away 2a. So what I'm doing is this equation minus this equation, 4 minus 0. 4a minus 2a is 2a. b minus b is 0. Therefore, a is 2. If a is 2, let's substitute that into equation 1. And we get 4 equals 4 times 2 plus b So 4 equals 8 plus b. So therefore, b has to equal -4. And finally, we substitute all of this into our equation, and we know y equals 3 when x equals 1. So I'm just going to use, say, a different blue. And finally, replace y. See the equation ax squared plus bx plus c. If you put a 1, y equals -3 when x equals 1, and a is 2. So 2 times 1 squared. B is -4. So 4 times 1 plus c. So -3 equals 2, take away 4 plus c. So therefore, -3 equals -2 plus c, so c equals -1. And we can finish now, because a is 2, b is -4, c is -1.